All right, so I want to start off by taking a look at an animation that Mark was showing you at the start of class. So I'm gonna go ahead and share my screen. Okay, can you all see what I'm showing here?
Yeah.
Okay, good.
Yeah.
So I think, correct me if I'm wrong, but I think Mark, by the end of class yesterday, you had talked about what P of n and F of n were representing here. So today I want to focus on G of n and H of n and talk about that, what those represent. So basically I have my value of n going back and forth. Hopefully you can see this green shading between this function f and the x-axis. So as that's animating back and forth, just keep an eye on these four values here, p, f, g, and h. Based on what the function is doing, what the animation is doing, and the values of g, what do we think G of n is giving us a value for?
The area underneath the curve.
The area underneath the curve. How do we feel about that?
Or the area underneath the 0 value.
Okay, so you got the area underneath the x-axis. A little more specific. Anybody else thinking anything a little differently? All right, so Rand, why are you, what leads you to believe it's the area below the x-axis?
Because it said not a number until you reached until you reached 2, and then it started counting from there.
There you go. Okay, so we're not accumulating any value until we get to x equals 2. And then what's always true about the value of G after that?
It's always negative?
It's always going to be negative, right? So that should give us another clue that, yeah, we're looking at area underneath the x-axis. All right. And since that area underneath the x-axis is negative, does that mean we're looking at signed area or unsigned area?
Signed area?
That's a signed area. So, and that's one, and I know we just started talking about this yesterday morning, but I think it's kind of easy to, especially early on, to get confused between what signed area is and what unsigned area is. But basically the difference is this. It's called signed area because it can be positive and it can be negative. It can take either sign. So that's how it gets the name signed area. So let's do this now. Let's come up with a mathematical expression for G. So I want to write a function. And basically what this function is going to do is this. It's going to give me any negative area between 2 and some value x. So someone give me some advice here. How would I write that function to give that value?
The integral from 2 to x.
Okay, we need an integral from 2 to x of what?
F of
Is it f of x dx?
Okay, got to vote for f of x dx. What do we think about that? In the chat, Tony agrees.
Do you have to like change the variable because it can't be the same as it is in the integral?
That is correct. I do not want to call
f t dt, yeah.
So yeah, basically I have to avoid x. Can someone give me a reason why that is? Why can't I integrate f of x dx?
B0?
I'm sorry, what was that?
Wouldn't it just be 0?
No, it wouldn't just be 0. But let's do this. Let me put it back to f of x dx. So in this function, what does x represent? What is x doing?
Gonna get an unknown number, right?
Yes, it's going to be an unknown number. But is it an unknown constant? Is it variable? Is it some unknown constant parameter? Like what is x in this
The
situation?
upper x-axis limit for the integral.
Okay, so it's the upper limit for the integral. So if you look at x as the upper limit of the integral, then it's going to be a constant parameter, because basically whatever I put in for x, I'm integrating every value from 2 up to whatever that value is. It's going to be a constant. But if you look at x inside the integral here, those things are varying. I want this variable to take every value from 2 up to whatever this upper limit is. So basically, I don't want x to be treated as a variable and as a constant parameter. So I don't want to use both. I don't want to use the x for both of those jobs there. So what do we think about this integral the way it's written?
It's good.
Should be good, right? All right, so let's move on to h of x now. So again, looking at the way this animation's going and these different values, what value is h giving us?
Total area above and below the curve.
Okay, total area above and below the curve. Is that going to be signed area or unsigned area?
Signed.
Okay, I got one vote for
Unsigned.
signed.
Unsigned.
I got one vote for unsigned.
Unsigned?
I got another vote for unsigned. So the first word we had to describe this was total area. So total area, unsigned area, you can use those terms more or less interchangeably. In fact, when you first learned about area, you probably learned of it as something that was always non-negative. It doesn't really, geometrically, it doesn't make a lot of sense to talk about negative areas. Just for the same reason that it doesn't make sense to talk about negative length. So what about this animation, or what about anything in this situation is telling you that this is an unsigned area?
H is always increasing.
H is always increasing. And Shannon says unsigned because it only takes positive values. Those are both good ways to look at this. So I think this becomes even more obvious when you see what happens when the green area goes beyond x equals 2. If H was signed area, you would expect that number to be decreasing when it's below the x-axis like that, but it's not. So it definitely is unsigned area. So knowing that, let's write an expression for this function. So how would I get started here?
Could you start with like absolute value and then an integral from 0 to x, or whatever that point is?
Okay.
Point eight. Is it 1?
Yeah, the beginning point is 1. So let's do this. You said, oh, no. So the absolute value of an integral from 1 to what?
Is it 3?
If I wanted to take the whole area, yes, but I want to start accumulating area from s equals 1, and I want to have some control over where I end this integral at.
So wouldn't it be x?
Yep, be x again. And what am I integrating?
F of t dt.
Right, how do we feel about this?
Wouldn't that still give you decreasing after you get to the 2? You just wouldn't ever get a negative value.
Right, and it's a very, very subtle difference, but I'm actually glad this came up. This did not come in my last hour. So I'll talk about this a couple different ways. If you take the absolute value of the integral, then all you're really assuring is that this h of x will never be negative. But let me see if I can stop this and put it in another function here. Where is, oh, I don't want to show that yet. Let's call this function k. This function here. So the absolute value, Control Shift I. All right, and let's play this again. So if you look at h of n and k of n, we know that h is signed area. We already covered that. K, we are hoping is unsigned area. Right now, everything's positive, so those are going to have the same values. But watch what happens as x progresses beyond 2. What is happening to k? So k, basically our try didn't quite work. So what modification do we need to make to this function here we defined for h?
You would move the absolute value to put it around like f of t dt.
Yep. And I don't know if I can do that without deleting everything. Let's try. So from 1, nope, that is the wrong thing to do. So I want the integral from 1 to x of the absolute value of the function. So what this will basically do for me is if the value of f of x or f of whatever gives me something negative, then I'm going to go ahead and make that positive. That way, every accumulation I give to my area will increase it. It'll be positive. And Alan asked, we use the absolute value because it's unsigned area. Yes, that's correct. We want every area added to be a positive accumulation. Any questions on this? Other question in chat? Okay. So let's do this one more way. How would I define this without using the absolute value operator? So I still want h of x to give me any area accumulating from x equals 1 for any value up to any value of x in the interval from 1 to 3, but I do not want to use an absolute value. So how would I get that done?
You could write 2 separate integrals for the time period at 2 where it switches to negative.
Okay.
And then the integral that's going to be from the x interval, or for the integral for the x interval from 2 to whatever that value is when it turns to positive again, you'll just make that value negative. So instead of using absolute signs.
All right, so there was a lot of stuff there, all of it good, but let's take it piece by piece. And the first thing I heard was what we really need to do is treat this as two separate integrals. And really we need to look at this as a piecewise function. Because as you're probably already noticing, the behavior of this function is going to change pretty dramatically when x equals 2. So we already know our piecewise function. Where's a good place to divide it? Basically, I have to divide my x interval into two different pieces. Where is that break point going to be? Like, where do I want to make that division of my x-axis?
At 2.
At 2, right? So my first one, I'm going to do this. If 1 is less than or equal to x, which is less than or equal to 2, and the bottom one's going to be if x is less than 2. Nope. 2 is less than x, which is less than or equal to 3. All right, so let's handle the first part first. So again, remember, I'm always assuming that I'm going to start accumulating area at x equals 1. How am I going to find my area if my x value is somewhere between 1 and 2? How would I find that?
Would that just be the g of x equation?
It would be similar to g of x, but we're going to have to make a couple of small changes.
Starting from 1
Starting from 1 and ending where?
at 2.
Going to x.
At x, right? So remember, I want this to be general. Like, for example, if x is equal to 1.5, I don't want to integrate from 1 to 2 because that's going to give you more area than I really asked for. All right, so integrating from 1 to x, what am I integrating?
F of t dt.
F of t dt. All right, how do we feel about that? Good. All right, so I like the first part of this function definition. How about this second part? What happens if x is between 2 and 3?
Would you have to do like two different integrals? So you would do like the integral from 1 to 2 of f of t dt.
Okay, so let me pause you right there. So the integral from 1 to 2 of f of t dt. All right, so you gave me an integral that does, basically this integral has no variable to it. This is going to give me that whole area, basically that whole positive area, green area above the curve there. So why have you decided to give the upper limit of 2 instead of something variable?
Because like you're only using this function from 2 to 3, so you're always going to have that integral from 1 to 2 within that part.
Okay, that's very well said. So yeah, if I have an x value between 2 and 3, remember I always want to accumulate from starting from x equals 1. So yeah, I need that full area. Good, but we are not done here. What else do I need to add to this definition for any x between 2 and 3?
Would you do minus the integral from 2 to x of f of t dt?
Let's take a look. Minus the integral from 2 to x of f of t dt. All right. What do we think about this, everyone? Can someone tell me why I am subtracting and not adding?
Because the function, or because the integral is going to give you a negative number, and we're looking to make it larger, not smaller.
Right, that's exactly right. So yeah, for any x value between 2 and 3, that area accumulation is going to be negative. The signed area is going to be negative. So if I want unsigned area, I have to multiply by -1 to make it positive. Any questions about either one of those? All right, I'm going to go ahead and stop the sharing here. I'm sorry, did I have a question?
Yeah, so for the second part of that piecewise function, are we trying to show the net difference in area between like the two regions, or are we just trying to show the negative area?
No, and that's a good question, and I'm glad you asked this. So, yeah, I mean, I think you've kind of gotten used to seeing a subtraction as showing some kind of a net change or some kind of a difference. But remember here, even though I have a minus sign there, I'm not really subtracting. So what is the minus sign really there to do for that second part of this integral, or the second integral for this function? Let's just think about this part that I'm highlighting. What can you guarantee me? So what will the value of this highlighted piece here, what will that value always be?
Negative.
It's always gonna be negative, right? Always gonna be negative. So I'm taking unsigned area though. So I don't want to add negative numbers to my accumulation. So the way to avoid that is subtract away this negative number. That will really and truly make this function h, this piecewise function h, it'll make sure that two important things, it's always positive, and as x increases, h also increases. Does that make sense? Any more questions before we move on to something else?
So to put it in a different way, are we kind of just like adding the absolute numbers up, and because of that 2 less than x less than equals 3, we're only getting that negative part in some way?
Yeah. Really, so I hope this doesn't confuse the issue more, but I think when people see, this symbol, we're kind of hardwired to think negative or subtraction or decreasing somehow. What this sign really means is the opposite.
It's
the
adding.
opposite of. So this second part is going to be a negative, right? That integral right there will always, 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 for any x inside this interval, it'll always give me a negative number. But I want to treat this number like it's positive. So since this number is always going to be negative, and I really want it to make it positive, I use minus sign to get that opposite quantity. Basically, if this integral yields the value -2, I really want that to be +2. So I'm adding -2. Really hope that didn't confuse the issue further, but bottom line here, we're looking for our accumulation always to be increasing. Our area for unsigned area always increases. Good questions though. Anything else? All right, I'm going to go ahead and stop the share. So if you haven't already done so, please go to your ASU email and open up the file that I sent out. We are not going to be